terms of Prosperous, our background, if you like, my day job is as a consultant as part of Prosperous. Within Prosperous, we have an experienced team of town and including town and country planning, architecture, renewables, and project management. And in recent years, in fact, this year we've consented our 100th megawatt of renewable generation. So our focus has very much been on the delivery of renewable energy projects, in particular support around consenting and installing renewable energy projects. But we have been involved in some really exciting projects, including Swap and Prior Heat Network, which seems to get very good coverage nationally, and the Blenheim Park decarbonisation work. One of the advantages of being involved in a small owner-led business, though, is you can get to choose what you do to some extent. And so as part of that, and given our interests, we set up Equality Homes 4 years ago to look at opportunities for developing a new model for home ownership, specifically targeting those that are locked off the housing ladder due to increasing prices. So whilst our focus is on the provision of low-cost housing or more accessible housing, I guess, we're also very interested in developing low-carbon housing. So Equality Homes was incorporated in 2018. We secured an option agreement for a site in Kirby Stephen last year and successfully consented a small site of 22 dwellings this year as our pilot site, if you want, to concept. And more recently, we were lucky to receive funding from the Rural Community Energy Fund, distributed by Local Energy Northwest, to do a feasibility study into a low carbon heat network for the scheme that we've expanded slightly to include other aspects, because we think that's going to add value to the end solution in terms of its replicability outside of the site. So in terms of the main scheme, the development for 22 units, we're currently negotiating with the planners in terms of the Section 106, but we certainly hope to complete next year. Although, like many, I'm sure we're having to reconfigure our development model in light of the changes to funding for community projects. But we're working our way through that maze. In terms of the low carbon energy system, it's because it's not going to be built out until next year, we're going to miss the renewable heat incentive, which has been very successful at driving low carbon heating systems forward over the last few years. I think it's also fair to say that the challenges of providing low cost or comparatively low cost heat is enhanced by the fact that Kirby Stephen does have an existing gas network, mains gas network, which adds to the challenge of competing successfully with that on a cost basis, which is further emphasised by the relatively low solar irradiance for Kirby Stephen, and that becomes an issue in terms of looking at the renewable generation options for the site. However, by building in low carbon or into the project at the outset, we think we've given ourselves a few additional pathways to deliver a truly competitive or low cost, low carbon solution for the scheme. So our platform has been about designing energy needs out of the site. And whilst we haven't yet concluded our work on the design, we're doing both together in parallel. We're looking at a low carbon design in parallel to the energy systems that we're doing. What we've also done is we've ensured that the layout suits renewable generation, making sure that we have south-facing roofs at the right orientation and inclination. And beyond that, we're also looking at a range of new technologies. I think technologies that will hopefully transform the landscape that we work within over the next 10 years. And also at other opportunities, both in terms of reducing carbon, but also in terms of the opportunity to generate revenue. So for community schemes, in terms of cross-subsidising them and making sure that they are low cost, looking at opportunities to use EV charging as a revenue generation opportunity from the wider community, if you like. I think there are a range of different angles we're looking at in terms of the project. So in terms of the feasibility study, then it really falls into two parts. There's the electrical side and the heat side. But for electrical, we're largely confined to solar PV on the site. So we're interested in what we're going to be able to generate from the solar PV, and just as importantly, when, both seasonally and during the day, that the profile seasonally and day profile for that. We're also interested in what battery storage can offer, and particularly in partnership, the relationship between battery storage and emerging variable low carbon grid tariffs, where you can source electricity from the grid at low cost times of the day and avoid the peak rate. So we're interested in that relationship. And there are a number of suppliers out there, but Octopus is certainly one of the leading ones, I would suggest. In terms of the heat, we're going to look at a wide range of options for heat. Our base case will be direct electric heating using hot water heating and radiant heaters, and that will form the sort of lowest capital delivery solution for the scheme. And then the question is, can we deliver a better option for that? And in our case, we're particularly interested in terms of, can we deliver one that's likely to be scalable beyond the boundaries of the site, both within Kirkby Stephen and potentially other communities more widely. So we'll be looking at different technology options. The first being individual air source heat pumps, which are sort of one of the front runners for delivering low carbon heat across the country, given the limited constraints that they face in terms of space requirements. But we'll also be looking at ground source, at what I would describe as, I guess, as a traditional ground source heat pump system, which is where a shared system, where you have a single heat pump using boreholes that provides the heat to all the homes on the scheme, the traditional way of doing it. But there may also be more effective means of delivering the system, and until we've sort of done the modeling, we don't really know in truth. But two of the alternatives we're looking at is an ambient network. So that's where you use a ground source network at ground temperature, but it supplies ambient temperature water to each of the homes. So a heat pump in each of the homes can then provide the heating for those homes. I guess that's a like-for-like swap for the air source heat pump. All you're doing, though, is you're providing water at ground temperature to the homes for their heating needs, which should offer some efficiency benefits. The question will be is whether the upfront capital costs can be overcome by the additional efficiency or the efficiency improvements offered by that scheme. And then we're also going to be looking at a hybrid version of the ambient network, which is to use the ground to store surplus energy during the lower cost seasons or times of day, for that matter, in terms of increasing the temperature of the ground network, primarily during the summer, just to improve the efficiency of the system over the following heating season. And in addition to that, we'll be looking at a range of options, including heat batteries and heat recovery. When I talk about heat batteries, these are emerging technologies. They're phase change materials, offering instant heat when you pump water through them. So essentially a plug-and-play solution that could potentially remove or replace the role for conventional domestic water systems and boilers. And I think where they are particularly interesting in terms of their longer-term role in combination with heat pumps is that they potentially overcome one of the issues you have with a low temperature heat pump solution, which is the most efficient way of delivering heat through the heat pumps, but with the issue of Legionella in domestic hot water systems. So if you can remove a traditional domestic hot water system, then you perhaps look at options of successfully using lower temperature heat pump options for housing and get the benefits of higher efficiency. So in terms of what we're going to be doing, we've started this process in terms of some of them, but we're looking at, from the solar PV point of view, is what we're likely to generate, accounting for orientation, angle of the roofs, shade and irradiance forecasts. For the heat options, we're looking to establish the load both at a daily and seasonal level, and therefore work out the sizing and the constraint issues for each option, and the design options and issues, before we can then start to, or on the back of which we can then start to assess the costs, both the capital costs for installing those systems and the operational costs. And then using all of that information and the actual general electrical loads for the buildings, the non-heat loads, we'll be able to set that through a commercial model to be able to work out which is the most cost optimal model, in light of the broader constraints and risks and issues that those systems will face. And ultimately, we're hoping to come up with a model that will not only offer the best solution to our site in Kirkby Stephen, the new build site, but also one which offers scope to be extended more widely, both in terms of bolt-on options for this scheme or replicated elsewhere to cover both new build and existing housing schemes. So that's what we're doing in Kirkby Stephen. In truth, I'm afraid to say that we're probably a little early to be presenting today. It'll be a couple of months before we've got useful data and results to talk about. So I thought it might just be useful to talk about another project that we're also working on that's a little further ahead in terms of low carbon energy generation. And I'm referencing this really in terms of the fact or to the changes to the support mechanisms for both heat and electrical low carbon generation, in terms of the industry suffered the electrical renewable industry suffered a significant setback when the feed-in tariff was removed, and I suspect the heat sector will also find increasing challenges next March when the renewable heat incentive is removed. But in this case, we were looking at providing a local business, a Scottish business, low cost, low carbon generation, because they're seeking to expand their core business, or to expand their business, but aren't able to do so on the back of the cost of electricity. And electricity is one of the core overhead costs for this business. So they asked us to have a look at the site. The site itself is grid constrained in terms of the amount of grid capacity that's available. There's fairly stringent planning policies restricting height for wind turbines and scope for wind turbines. And the modelling showed that on its own, solar PV was only able to reduce import demand from the grid by about 50%, which wasn't enough to ensure that this project is viable. So what we did in that case was we've developed a model using 10 years worth of hourly data for the site, based on wind resource and solar resource, in order to develop various scenarios and then fine-tune the supply mix for that site, allowing for both solar, wind and battery storage. And by doing that, we've been able to increase the self-consumption aspect of the project, the ability to generate and consume on site your own energy, from 50% to 80%, and reduce the actual installed capacity of the system in terms of relying solely on one technology, which in this case, the base case was solar PV. So that's certainly moving that project towards from an unviable project to a viable project. And there's a bit more fine tuning we can do by looking at some of the emerging low carbon variable grid tariffs, and combined with battery storage technology. So where you can look at weather forecasts and then opt to charge your batteries day ahead based on what the forecast is for the following day. So in this case, I think the key message really is that what it shows is that despite the loss of the tariffs the feed-in tariff particularly, that drove the development of low carbon electricity generation, it is still possible to develop projects that offer substantial savings for on-site consumption. In this case, we're able to offer the client a saving of around 50% on the cost of energy for this project by looking at a range of sensibly sized and balanced technologies for the project. So in summary then, the loss of the renewable heat incentive is going to pose a challenge to many projects. Having said that, having worked in the renewable industry for over 15 years, I actually see this as being a really exciting time to be in the low carbon sector. Despite challenges, we are seeing significant savings or reductions in the level of carbon. In fact, I think we're seeing changes that were, to me at least, unimaginable 10 years ago. And we're seeing new pathways to low carbon living, low carbon generation opening up all the time. And I think for those of you out there like me that are looking for rays of light in what can be a darker tunnel at times, I think what's happening at a national level, as I think Chris referred to at the outset of the talk this morning, in terms of the national electrical grid, it is really quite heartening. We've seen the level of carbon, the carbon content, if you like, carbon dioxide content of each kilowatt consumed from the national grid has fallen since by half. Has halved, if you like, since 2014, and is due to halve again by 2035. So I certainly see that as a chink of light at the tunnel. And in terms of our experiences with work we're doing on projects, I certainly think it's possible to deliver low carbon and low cost solutions. Not always easy, but it's still possible, and often just takes a bit more effort to think around the issue and to design it in from the outset, to build your solution around that vision of low carbon living. So that's me. Thank you very much for your time, and I think that gives us a bit of time for some discussion now. Okay, so I'll
perfect. Thank you so much. I mean, like you say, it's early days, isn't it? And all these different elements are constantly changing. So we're having to adapt and look at what models will carry forward. And it seems like there's a trail of thought at the moment that we have to model these things and, like you say, find bolt-ons for different scenarios, because each site is going to be different. There's going to be different light, sunlight, and so we'll have to. They have to adjust to the precise site that we're looking at. I'd be interested from the group, what's your experience of this? Did you, is this a kind of the start of looking at energy, maybe storing energy on site if you're looking at building on a site at the moment, or what your interest in this particular session might be? Good to hear what your thoughts are. Thank you, Derek, by the way, as well. Thank you very much for your presentation, sorry. So over to whoever.
Hi there. Just, I suppose my particular interest is slanting more towards the retrofit and the community-led initiatives that might look at these much lower carbon alternatives to energy, and the particular comments that Chris was making at the beginning around the home energy retrofitting alternative heating systems and encouraging people to think differently about where their energy comes from. And Derek, certainly the presentations that you've just been running through, you know, it's pretty compelling, the way the technology is changing. And I suppose what I'm particularly interested in are the kind of arguments based on the technology, the costing of renewables over the long term, the arguments that we can make to people to move from one form of legacy heating, particularly heating homes, to something more renewable. And I suppose it's particularly their existing homes, I suppose, rather than trying to, I mean, to be honest, to me, it's a no-brainer to design. If you're starting from scratch, if you're doing new build, then absolutely you should be thinking 21st century technology. And I suppose the work that we're doing is more to do with encouraging community-led action that will quicken the transition for households from one to the other. And so particularly, I suppose, focusing on the air source technology, I suppose, as the most likely choice. But based on all of the other technologies that you've talked about, how do we convince people that they need to do this sooner rather than later?
I think that's a really good point, Tim. I guess I see us at really a transitional point in history, and the work we've done at Kirkby Stephen, new build granted, just goes to show that the traditional energy models that worked 10, 15, 20 years ago don't necessarily apply now. The rules that you had to stick to a kind of a gas boiler, because that was the way it was done. I think that whole way of thinking can change, and there's a lot of work to do to get that message out there. But I think there are new technologies coming through that will allow us to do that. And I think to some extent, though, you've got to prove that they can work to what may be a skeptical audience in the first instance. I mean, I take our house, our street. I live in a street built in the 1930s, and we sort of work our way through it, improving the energy efficiency. But we've got a gas boiler, and at this point in time, we're probably challenged to find a sensible alternative that's going to offer a low-cost, low-carbon solution for us. And in part, if I'm being entirely honest and truthful, I think that's what's driven our desire in terms of Kirkby Stephen to look at such a wide range of options for the energy system there, because it's not. We could probably design homes in Kirkby Stephen that are passive. You still need to provide the hot water needs, and there's all the other electric needs, but you can design out most of the heat. But that's fine for the new build homes. But most of the homes that are going to be in 2050 have already been built, and that's obviously the core market. So I think there are options in truth, and one area I'm really keen to explore with our work, I can't give you an answer today, sadly, but is this opportunity for using shared heat networks, but not necessarily community heating schemes that are providing hot water to people's homes, but as an alternative to air source heat pumps, which are less efficient than the ground source heat pump systems, but instead of but providing ambient water, for example, or slightly warmed ambient water to homes. I do think for community style projects, so we probably need to be bolder with our vision in terms of how we develop energy systems that are more cost effective. One of the biggest stumbling blocks with air source heat pumps is that I'm not sure about you, but the rate I pay for my electricity is 17.9 pence per unit. I can tell you that because I had my bill yesterday. And that means that air source heat pumps or ground source heat pumps are always going to be faced with a challenge, because even with a coefficient performance of say 4, you're still paying a higher unit cost for heat than you are for a gas boiler. And that's before you count, you build in the cost of the capital cost difference between the two technologies. So I think in terms of community energy systems, I think the starting point is say, right, how do we change that, readdress that balance? And there are opportunities there. The work we're doing for renewable energy systems generally show that you can supply electricity to homes if you do it behind the meter for 6 pence a unit. And that means if you're then working with a coefficient of 4 for your heat pump, your input electrical costs have fallen to substantially less than gas. So to me, that's the starting point for community energy systems, is to readdress that balance. So you're not paying the highest rates for your input energy, And that, I think, gives you a fighting chance in making sure that your higher capital cost equipment can be funded. I think the second point then is to look at how, if you are putting in boreholes as a solution instead of heat pumps, for example, look at options for how those are funded. Once you've put in a borehole and a pipe, I wouldn't know how long they would last, but I'm guessing they'll have a life of at least 100 years. I mean, there's no moving parts. You shouldn't have to refund or repay that investment over 5 or 10 years. There must be opportunities out there as an infrastructure investment to develop schemes that you can repay over 50 years. So again, I think looking to try and rebalance the cost difference between the different technologies, and give these heat pumps a fighting chance to compete on like-for-like terms with gas. So those are sort of the options I would be looking at. And in fact, those are the options we're starting to explore in other projects. And hopefully in time, we'll be able to give you some updates on how successful we've been.
It does seem that is the key problem at the moment. There's these new emerging technologies for England, although some have been tested elsewhere with different climates, but that we have to model these things first to be able to work out what's going to work for each different potentially community-led plot and building site, I presume, as well. So it's a lot of different parts to be brought together, isn't there?
There are. I'd actually, Kay, just like to go on and say, actually, I don't think we necessarily need to prove the technology anymore. I think largely the technology is proven, and the renewable heat incentive and the work that's gone on around the world has done that. But there are certainly emerging technologies like heat batteries or battery storage generally that probably still needs further work in terms of proving. When I talk about proving the technology, I'm actually primarily focused now about proving the commercial model in light of the changes to renewable heat incentive. How do we provide technologies to homeowners that they can afford, that they don't have to pay an arm and an leg for, by comparison to replacing their gas boiler, which they know and understand.
Of course, there's also the bit. Yeah.
Hello, sorry, I just sort of looking at this from the other perspective, and I know this is sort of weird because in the UK, heat is the bigger issue, but also, of course, we're seeing summers becoming increasingly hotter. And I remember reading last summer the increased use of fans and the increased use of electricity as a result of fans. And I'm wondering if there's something around the borehole thing, because I know it's an ambient temperature, that would actually decrease the use of, you know, is it a multi climate thing? Does it actually keep the house cool as well as being able to heat the house as well? Or is there something else that we need to be looking at, as temperatures do seem to be increasing in the UK at the moment in the summer months?
Gavin, you raise a very good point. I guess my outlook's slightly different as I live in Scotland, and the project we're developing is in north of England. So cooling isn't such an issue in truth for us. But the technology, and particularly the use of ambient networks, is ideally suited to providing cooling as well as heating, because in effect, by cooling buildings over the summer, you're increasing the temperature and storing that heat for the winter in the ground. You're using the ground to provide interseasonal storage. And there are a number of projects around that have shown that to be very successful. The challenge, I think, for all of these projects is to find a way of overcoming those capital costs when you're starting up that system. But certainly there are projects around that use that system in reverse over the summer to provide cooling and help then store that warmth for the following heating season.
So is that the main barrier at the moment, is the initial cost of putting in the I don't know what the infrastructure would involve for the borehole, and the creating a passive house that obviously manages to maintain the ambient heat or coolness? Is infrastructure investment the main barrier? I
don't see necessarily infrastructure investment being the main barrier to developing solutions for new build properties. But I do think it's a significant barrier to developing low carbon systems for existing properties, where you're having to do a lot more engineering and provide a lot more technology because they just don't meet the same standards.
Thanks.
It's really tricky because we've got embedded energy as well, haven't we? I mean, if gas boilers are going to be taken out of properties and replaced with new things, I mean, what happens to those boilers as well? So you've got the embedded energy to think about within the existing setups as well, haven't we? So if we are retrofitting, how are those old boilers going to be recycled? What's the energy? It's not energy for heating as such, but there's still an element there to be considered, isn't there? I don't know if you've got any thoughts on that at all.
Not specifically, Kay. I mean, I would imagine. I mean, the advantage of the embedded systems, they will largely be metal, and therefore, as a result of that, they will have a high recyclable content. And obviously, recycling metal delivers significant carbon savings over the new material, the raw material.
Yeah, good point. Chris mentioned earlier that there might be a change of incentives. So it might be the incentives or tax incentives might go away from electricity and away from gas and more to renewable energy sources. Do you see that coming through? Have you had experience of that at all?
Interestingly, I've not. I've often, it's a double-edged sword, of course, because you don't want to increase energy costs, but I think it is very challenging to come up with new emerging technologies when the incumbent technology is so cheap, and gas remains very cheap. So I do think we need to find ways of addressing that balance. And one way to do it would be to increase the cost of gas, to encourage people to adopt and take up low carbon alternatives.
Well, that's going back to your point, Tim, isn't it? The incentive for changing technologies. That's what we need to be looking at, which is being tentatively looked at, I think, now. And how community-led organisations and housing can take that forward is quite a challenge, isn't it? Because as we've heard before, it's usually people doing it in their own time. So it's kind of galvanising a force who can promote those technologies, I suppose. I see we're about to go back out into the main room. If there are any further questions that you'd like to follow up about energy source, please do put them in the chat and we'll follow them up after. Other than that, thank you very much, Derek, for your presentation, and we'll see you back in the main room.
Yes,
you want to press the...
Thank you all.
Thank you.